I'm Tom Urim. I'm from the Leadership Computing Facility, and I'm going to talk to you about Balsam today. Um, so just to give a brief introduction, I think much of what you're learning at CPW has to do with running large-scale parallel applications and effectively using the hardware. Um, there's another approach to using the systems, which involves instead running many instances of individual applications or collections of smaller parallel jobs. And very often projects end up in this place, having built up their own infrastructure for doing this. And so we've been developing Balsam to provide this functionality for projects that need it. And then to try to do that as efficiently as possible on the back end while making it easy for users. So there's a short description here. We're at the Balsam demo portion of the workflow of the workshop repo. And Balsam is open source developed. So the first link that you see there is to the GitHub repo. And then here there's a link to the full documentation for Balsam. So the core of Balsam uses notions that you're of course already familiar with in terms of sites where you run codes, the applications that you run there, jobs that you declare that should be run, and then submitting batch jobs. And you'll see all of these things show up in the tutorial that I'll walk through. I just put at the top of this page some simple commands for listing each of these things: your sites, the applications, the jobs, and batch jobs. So Balsam manages sites in a way where you set one up. Say I set up a site on Theta GPU, and it's registered with a central server. So the server itself knows about that site, and I can query that site using a command like this one. And I can query all of these other things relative to that site using similar commands. If I have multiple sites, I can query all of them across using these simple commands. So we'll walk through this. Getting started, you just, from a Theta node, you can clone the workshop repo. I assume you've already done this. You could paste in this collection of commands here. This basically creates a virtual environment and installs some necessary Python modules, including Balsam. And then you log into the Balsam server. The Balsam server is an opt-in server. You have to be added to the server in order to be allowed to access it. All attendees of the workshop have been added to that group. So you should all be able to issue Balsam login. And in that case, it will take you to an ALCF login page where you can log in, and then on the back end, it will communicate and you'll be authenticated to that Balsam server. More detail than you needed to know. Once you've done that, you can load the Cobalt GPU module so that you submit to Theta GPU instead of Theta KNL. We're just doing that for the demo. You could just as well submit to Theta KNL. And then you create a Balsam site. In this case, we're naming the site, and details of the site will be created in this directory. So we named them identically, but this just creates an area where Balsam will run jobs and store job data as it runs them. And then we start the site. This is basically starting an agent that runs on the login node in this case to communicate with the server and pull in jobs and push job state back to the server so that it's accessible from that level. So for the purposes of this workshop, I created a very simple Hello application. There's a little bit of Python code. This resides in the repo, and to add that application to the Balsam site, you just run it. It's a very simple wrapping of the command that will run here. We take this approach because we want to make it as simple as possible for you to integrate your applications in here. We all start running command lines, and so that's our currency, and that's what we work in, and that's what you should provide here. So we have as little Python code as we could to integrate this. And then there's a sync command, which just sends the application definition up to the server where it's accessible to the site. There's some details here that maybe I could gloss over, but I'm just including them to sort of give a full description. Once we have that app defined, we can create a hello job that uses it. And there's a script in the repo that does this for you. You can just run that script. And in this case, it will create a job for that app on the site that you created. We specify a work dir, which will be created inside of the Theta GPU tutorial directory that was created above. We specify the value of this say hello to parameter on the command line. And we can tag the job with any number of key value pairs, which make it easy to manage our job database later on. And once that's done, we can list jobs that we've created. And again, we specify the tag so that we only get that job that we care about. Now, if I did that, you see I've done some previously. And there's this one that's staged in. That's the one I just created. And this is printed, of course, at the end because I listed my jobs. Once that's done, now that the description of the job is in the database, and I could submit a batch job to run that one. Okay. I had a typo in my script. So now I ran that again, and if I look at jobs that I have these jobs queued on the site that's named Theta GPU tutorial. With some delay, there's typically some delay while Balsam submits that job, but if I now if I issue QStat, I see that that job actually exists in Cobalt. I'll break here just for a second in case people are trying this to say, one, that we will actively monitor Slack to help with questions as they come up. Yeah, okay, so there's a question in Slack now. When you Balsam log in, it will give you a URL and it will tell you you have to visit that URL in order to authenticate. So you'll have to copy the URL from the terminal into your browser and open it, and then you'll be prompted to authenticate. All right, and when you're done, then that Balsam login prompt will return as soon as you finish authenticating on the web page. Yep, no worries. Right. Okay, so there's a question in Slack about an invalid request on the authentication. As I mentioned, the attendees of the workshop have been added to the server so that they should be able to authenticate this way. That will work except in two cases. One, where we had some incorrect usernames on the list, and two, it may not have propagated yet so that you have access to the server. You should have access to it. but I'll just clarify that we'll continue to monitor Slack through the workshop to help you out with any problems. Let me just check my okay, so I'm still queued. So I'll move on. And just note a couple of things. Here, when we submit this job, we're using the Balsam command line interface. And we try to do a couple of things. One is to mirror the typical options that you use when you use Cobalt. And then there are some additional options for submitting a job, which are Balsam specific. So you're submitting to the Theta GPU tutorial site and tagging the application and giving a job mode. We'll come to job mode later. So what should happen in this case then is that you created a job, you submit a job, and the site will take that job and submit it to Cobalt, monitor that job, and when it's done, it will post that status back up to the Balsam server. And if I looked at this, then I'll see this state change to job finished when it's done. I can monitor those states all through the run of the jobs. But this simple example just demonstrates the round trip of describing a job, submitting a job to the queue, and having it run. What Balsam does when you submit the job is it holds that queued job and runs as many jobs as it can from the database inside of that job, so that you wait once in the queue, but you run multiple jobs within that Cobalt job. We could do something similar in the next example where we create multiple jobs, right? So in this case, instead of the command line, we're using the Python API for Balsam. So we just loop over over a range of 8 to create 8 jobs and append, set the parameter, the say hello to parameter, just to differentiate them. And we specify a node packing count of 8. So we get 8 jobs per node. There are 8 GPUs per node on Theta GPU. And we say that we should specify 1 GPU per rank. And then when that's given that list, we can make a single API call to bulk create those jobs. So we only make one call to the server. If I do that, same thing. And then here, instead of hello, I named the workflow hello multi. You can see I've created these most recent ones and some previous ones while I was working up to the workshop today. And I could also create dependencies between jobs. So in this case, I create, looks very similar to the last one, but each time I create a job, I specify that the parent job is the job that came before it. So these will have to complete in order. And if I run that one, and I changed this workflow name to hello deps, and you see we have a different status so that the first job is in pre-processed state. It will progress, but the other jobs are awaiting parents, and they're all just simple linear workflows, so they'll run in order. I should note here that this node packing count of 8 will allow Balsam to run up to 8 instances at a time on a single node, of course. But given the job dependencies, it will be limited to running 1. Obviously, it's inefficient because 7 GPUs would be left unused, but it's an illustration of job dependencies. And you can imagine how you would do this differently in terms of a much larger collection of jobs, or jobs that used one or a collection of nodes and had dependencies between them. Great. So we can create jobs. We can create many jobs, and Balsam will run them all for us. We've done this on Theta KNL, for example, to run millions of jobs across Theta KNL at scale, even a single job per core on Theta KNL using containers. And it was very efficient for Balsam to grab nodes for hours and then run many shorter jobs within those jobs, targeting individual cores on Theta KNL. We could do the same thing on Theta GPU, of course, and on future systems too. But when you run into that situation, then you of course want to know, monitor your jobs as they progress through their states. So there's an API for monitoring event changes, which will tell you about all of the state changes, including some initial pre-processing, file transfers that happen before the start of the job, when it's submitted, when it's running, post-processing that happens, and then file transfers out. And when I say file transfers, I'm referring to Balsam has integrated support for Globus. So you can specify Globus URLs and it will stage data in from other Globus endpoints that you have access to, run the job, and when you're done, the outputs can be transferred out to one of your Globus endpoints that you specify. I don't illustrate that here in the tutorial, but there's more information about that in the Balsam documentation. If I look at that, in this case, I just see many details like we saw before when I was listing jobs. And it doesn't look very useful, but the whole point here is that you can query these programmatically using the Python API and use it to get an idea of the throughput and the progress that your jobs are making. We also include some analytics. So you can look at throughput and utilization. This example grabs those events like we were doing in the previous example, and then generates a report, a couple of reports for throughput and utilization, and plots them. I don't give an example of those plots here, but if you walk through the examples here and run these, then you'll see these plots and you'll be able to see how the jobs are run within the Cobalt job over time. Again, in the face of these simple examples, probably these reports are not hugely useful, but at larger scale, it's useful to see how efficiently your jobs are being run. So there's another example here that builds on the previous ones. So I said that you can have sites running at multiple different, on different supercomputers, and then utilize them all individually. And also that you can have dependencies between jobs. So in this case, I'm back to using the command line API in order to create jobs. And I create one for each of these sites that I have set up. There's a warning here that this will only work if you have the same setup. So I created all of these sites, which I don't demonstrate exactly how to do here, but you could follow the examples here and set up these sites, and then this same thing would work for you. In this case, I've set them up for Theta KNL and for Cooley and for Theta GPU, and I also created one on my laptop. If I do that, then I get these jobs on all of these different sites. Okay, we'll fix that one. this one, I used this approach. And so we see I have these multiple jobs set up across these different sites. Sorry, I needed this one. So now you can see the 4 jobs that I created, and they're already progressing through multiple different stages. Just stage in is a no op in this case, there are no transfers. And we have one job that's in a pre-process state, but you see the multiple sites that the jobs on the multiple sites that I had. And then with let me make a quick fix to this one. I'll update these in the repo immediately afterward. Okay, so I just had the project set wrongly. And then I list these jobs, and you see the again, you see that I've queued jobs on these 4 sites. So the upshot here is that from one machine, in this case, a Theta node, I can submit jobs to run across 4 different sites and monitor their execution as time goes on. I point this out because now we've followed a progression from defining an application on one site to defining applications on multiple sites, running jobs, and creating dependencies between them. And in the case of a larger multi-site workflow with dependencies, you could set up such a workflow that would run, say, a collection of jobs on Theta GPU and some following dependent jobs running on Theta KNL or on some other system. And as you're building this up, you can rely on Balsam to manage that for you and create a lot of metadata along the way that you can track to understand how that workflow is progressing and how well it performed along the way. So I mentioned I would update this repo after we're done, and we'll continue to monitor Slack to make sure that things are working for everyone. I see some things in Slack now, so we'll follow up on those. Given the functionality I described, you could imagine defining a more complex example. And there is a more complex example that's linked here at the bottom. This hyperparameter optimization example uses Balsam to optimize parameters for CIFAR10. It's a simple model. It's a simple example. But in this case, what's done is that jobs with different hyperparameters are submitted, and there's an agent that uses the Balsam Python API to continuously monitor jobs as they complete and to allocate, to draw new evaluation points from the executed jobs to then make a decision about which jobs should be submitted next. And this will just run until you stop it. So there is this example that you could walk through when you get to the end of the previous tutorial content.